The question is whether that is a signature that 3i Atlas is technological because it wants to deposit probes or satellites around Jupiter.
The shock hits instantly. Without warning, Hubble's instruments register a sudden structural shift in 3i Atlas. Not a blur, not a tracking error, but a real change happening in real time. The comet no longer looks the way it did at discovery. Its nucleus brightens unevenly, flaring on one side while dimming on another. Scientists watching the live feed fall silent as the symmetry breaks apart frame by frame. This is not a distant frozen traveler drifting through space. This is something reacting. Ultraviolet sensors spike hard. Reflected UV light surges in short, violent bursts, the kind usually seen much closer to the sun, but 3i Atlas is still far too distant for this level of activity. The brightness doesn't rise smoothly. It pulses. That detail alarms researchers immediately. Pulsing means exposure of fresh material, not slow surface heating. Something beneath the crust is pushing outward, tearing through layers that should still be sealed after billions of years in interstellar cold. The models collapse almost instantly. Simulations built to predict comet behavior at this distance fail to reproduce what Hubble is seeing. Thermal estimates are wrong. Pressure assumptions don't hold. The nucleus appears to be changing shape, not rotating faster, but redistributing mass. One hemisphere grows brighter, while the other darkens, as if the comet is venting from specific internal chambers. This is not erosion, this is activation. Then comes the most unsettling detail. The transformation accelerates. Over successive frames, the surface contrast sharpens instead of smoothing out. New reflective patches appear, then fade, then reappear somewhere else. Scientists realize they are watching exposure events, short-lived openings in the surface that close again. That means internal pressure is building, releasing, and rebuilding. The object is not stabilizing, it is cycling. This should not be possible. Interstellar comets were assumed to be dormant relics, chemically exhausted, structurally dead. But 3i Atlas is behaving like a body that remembers heat, remembers stress, remembers how to react. The realization spreads quickly through the control rooms. This object did not arrive frozen and passive. It arrived loaded. As the data stream continues, one final warning appears buried in the telemetry. Energy output is rising faster than solar exposure alone can explain. Hubble keeps watching, but the change does not slow. It intensifies. And as scientists scramble to alert other observatories, one question hangs in the air, unanswered and urgent. If this is happening now, far from its most dangerous point, what will happen when another set of instruments turns its eyes on 3i Atlas at the peak of instability? The warning arrives without ceremony. From beyond Mars's orbit, ESA's JUICE probe pivots its instruments and locks onto 3i Atlas, and what appears on nav-cam screens immediately raises alarms. The comet's core is not faint or diffuse. It is sharply defined, dense, and wrapped in a coma that is expanding too fast to ignore. This is days before perihelion, a window when most models predict controlled heating. Instead, the brightness surges unevenly, flaring and dimming in pulses that look anything but stable. Engineers flag the timestamp. This is happening now. Then the tails split and refuse to behave. Two distinct structures pull away from the nucleus, separating cleanly instead of blending. One tail twists violently, snapping under solar wind pressure like a charged whip. The other thickens, growing denser when it should be thinning out. Plasma diagnostics confirm the first tail is electrically driven, reacting instantly to changes in the solar field. The dust tail, however, is doing the opposite of what physics predicts. It grows heavier, not weaker, as if new material is being injected continuously from within the comet itself. Scientists expected erosion. What JUICE is recording looks like construction. Material is not peeling away layer by layer, it is being expelled in bursts. Activity spikes arrive suddenly, faster than thermal models allow. These are not surface grains drifting off. The rate suggests sealed reservoirs are breaking open at once, venting pressure that should not exist in an object this old, this far from its home star. The comet is losing mass aggressively, yet its overall structure remains intact, as if reinforced by something unseen beneath the surface. Telemetry confirms it. This is not a slow activation curve, it is a surge event. Energy output climbs, drops, then climbs again, forming a pattern no one can smooth into existing comet behavior. JUICE is not observing a relic warming up. It is watching a system reacting, adjusting, responding. Each hour of data makes one fact harder to escape. 3I Atlas is doing something it was never supposed to do at this distance, at this speed, at this moment. And as JUICE continues to watch the outflow intensify, deeper instruments prepare to activate. Because if this surge is being driven from below the surface, the next readings may reveal what's really waking up inside the comet. The warning signs appear almost immediately, and they do not agree with each other. As data streams in from MAGIS, UVS, JANUS, SWI, and PEP, scientists realize they are no longer looking at a single unified signal. Each instrument is telling a different story, and none of them line up cleanly. Particle detectors register bursts of charged material surging away from the nucleus, far stronger than anything normally seen at this distance from the sun. These are not weak comet winds. These are forceful outflows, sudden and uneven, spiking without warning. Control rooms fall quiet as graphs begin to jump instead of curve. Millimeter wave readings deepen the concern. SWI detects rapid changes beneath the surface, subsurface layers heating, shifting, reacting too fast. This is not slow warming. It looks violent, like pressure building and releasing in short cycles. At the same time, ultraviolet data refuses to stabilize. UVS shows brightness fluctuations that rise, fall, then surge again, as if something inside the comet is pulsing. No rotation model explains it. No thermal curve predicts it. The comet is not behaving passively. It is responding. JANUS imagery adds another layer of unease. High-resolution surface scans show subtle distortions forming and fading across the nucleus, patterns that do not match erosion or cracking alone. These features appear, vanish, then reappear somewhere else. Researchers expect consistency. Instead, they see movement without motion, change without displacement. MAGIS confirms abnormal chemical signatures, hinting that fresh material is being exposed from below, not gently released from the surface. This is internal matter breaking free. The fear is not that scientists don't recognize the signals, it's that they do. These readings resemble active internal processes, pressure systems, layered volatiles, structures reacting in sequence. The word rhythmic begins to circulate quietly in briefings. Something inside 3I Atlas is responding to sunlight in a coordinated way, not randomly, not chaotically. That possibility changes everything. Interstellar objects were assumed to be inert, exhausted by billions of years in deep space. This one is anything but. As the data continues to arrive, one realization becomes impossible to ignore. These are not surface-level effects, and they are accelerating. Internal physics is revealing itself faster than models can adjust. The comet is not settling down, it is waking up further. Engineers flag anomalies for priority review. Scientists delay conclusions. No one wants to be the first to say it out loud, because if this internal response intensifies, the next phase won't be subtle. And the next data set is already on its way. The shock hits without debate. New data confirms something no model allowed for this stage of approach: eruptive ice activity. Not slow, steady sublimation, the expected breath of a warming comet, but violent outbursts, sudden, forceful, directed. Material is being blasted off the surface in short, powerful bursts, as if pressure trapped deep inside is breaking free all at once. These are not passive reactions to sunlight. These are explosive vents ejecting ice, dust, and gas into space with enough force to reshape the nucleus in real time. Scientists watching the feeds fall silent. This behavior is wrong for an object that has traveled cold and dormant through interstellar space for millions of years. Hubble's follow-up images confirm the danger. Bright patches flash into existence across the nucleus, then vanish. They reappear somewhere else minutes later. No impact trails, no debris clouds, no external cause. These flares are transient, short-lived, and internal in origin. The surface of 3I Atlas is not cracking from outside stress, it is venting from within. That means volatile material, ices capable of rapid phase change, has survived intact beneath the crust. Pressure is building, releasing, then building again. Every eruption alters the surface, exposing fresh layers that react even faster to sunlight. Each burst increases instability. Each flash raises the same unspoken question: how much pressure is still trapped inside? The implication unsettles the entire field. This object did not form here. It was born around another star, expelled into the void, frozen in darkness, and battered by radiation for eons. And yet it is not dead. Its interior is still active, still reactive, still capable of sudden release. That rewrites assumptions about how interstellar objects age, how they store energy, and how long volatile systems can survive. If ice volcanoes are erupting now, before peak solar stress, then the most dangerous phase may still be ahead. As 3I Atlas moves closer, heating increases, stresses compound, and internal layers destabilize further. Scientists are no longer asking if more eruptions will happen. They are asking when, and whether the next phase will be stronger, faster, or something no one has seen before. And just as that realization sets in, instruments begin detecting changes beneath the surface, signals that suggest the eruptions may not be isolated events at all, but part of a deeper, coordinated reaction still unfolding. December 19th looms like a deadline no one can delay. The moment Earth enters the equation, the rules change. Across the planet, ground-based observatories synchronize with military-grade precision, breaking routine schedules to lock on to 3I Atlas continuously. This is not curiosity anymore. This is response. The comet has crossed a threshold where distance no longer protects observers from consequence. At just 273 million kilometers, it is close enough for round-the-clock scrutiny and close enough for surprises to arrive fast. Radar systems begin probing its surface, searching for density shifts and hidden voids. Spectrometers tear apart its light, looking for chemical signatures that shouldn't still exist after a journey between stars. Thermal sensors track heat flow across the nucleus, and what they see is unsettling. Warming is uneven. Stress fractures appear to be forming beneath the surface. Some regions heat too fast, others resist entirely, as if insulated from physics that should apply equally. Models don't agree. Simulations fracture into competing predictions. No one can say which one is wrong. Scientists are no longer debating if something will happen, they are debating when. Past spikes in activity came without warning. Jets ignited suddenly. Brightness surged and collapsed. Now the sun's influence is stronger by the hour. Every increase in solar radiation pushes volatile layers closer to instability. Pressure builds. Internal reservoirs that survived interstellar space are now being tested in a way they never have before. The object is not relaxing as it approaches, it is tightening. Amateur astronomers around the world prepare their telescopes, expecting a rare celestial visitor. Many will see a faint streak, maybe a soft glow, and think they are witnessing history. But professional observatories are watching for something else entirely. Sudden flares, unexpected emissions, rapid tail reconfiguration, signs of fragmentation. A single spike in radiation could mean a new vent has opened or something deeper has failed. With every hour that passes, uncertainty compounds. The comet is not just moving closer to Earth. It is moving closer to conditions it has never encountered. Increased solar pressure, magnetic interactions, thermal stress. Each factor alone is manageable. Together, they form a test no interstellar object has ever been observed to endure this closely, this clearly in real time. This is no longer a flyby, it is a stress test unfolding live. And as December 19th approaches, scientists quietly brace for the possibility that the next data packet will not confirm stability but signal escalation. Because if 3I Atlas reacts again under Earth's watch, the question won't be, what are we seeing? It will be what just activated next. The warning lands without fanfare, but it hits harder than any alarm. Inside research centers across the world, scientists quietly admit what the data now makes impossible to deny. Every new observation is making the situation worse, not clearer. Each update from Hubble, each spectral pass from Earth-based arrays adds contradictions instead of answers. Brightness curves refuse to stabilize. Gas ratios drift outside known comet behavior. Thermal readings fluctuate as if the nucleus is reacting, not simply warming. This is no longer about identifying features. It is about admitting loss of control over prediction. 3I Atlas is confirmed to be natural, but that confirmation offers no comfort. It does not behave like an ordinary comet, nor like the two interstellar visitors before it. Its activity profile violates thermal decay models. Its venting patterns do not match rotational stress alone. Subsurface reactions appear delayed, then sudden, as if pressure is building and releasing in stages. Researchers now openly question whether the object's internal structure is layered, fractured, or chemically unstable in ways never observed before. Classification charts fail. Simulation outputs diverge wildly. The models are no longer leading the data. The data is chasing something unknown. As the comet approaches its closest observable window, telescopes do not blink. Arrays stay locked on target, tracking subtle shifts in polarization, particle density, and ultraviolet scatter. Small anomalies are no longer dismissed as noise. A faint spectral line here, a temperature spike there, a brief surge in charged particles that fades before it can be fully explained. Each signal suggests activation, not exhaustion. Instead of calming down, 3I Atlas appears to be responding to solar influence with increasing complexity. Something inside it is still adjusting and possibly destabilizing. The fear researchers do not say aloud hangs over every briefing. If this level of change is visible now, what phase has not begun yet? There is no evidence of danger to Earth, but uncertainty itself has become the threat. An object that rewrites its behavior mid-observation cannot be safely extrapolated forward. As the final data streams in before the next observation cycle, one truth remains unavoidable. The comet has not finished revealing itself, and whatever happens next will not wait for permission. The next phase is approaching, and no one knows what it will look like.